Hello and welcome to this video, which is part of a series of videos on how to write a function in C++. And today we are writing a function about Blackjack. The requirements for the function can be seen right here. These are the requirements for the function. I'm not going to read them, but you can either pause the video and read the requirements for the function, or you can simply find those requirements in the description of the video. Okay, without further ado, I'm going to get started with the writing of the function. So, if you have read the requirements for the function, you will have understood that the function needs to return, basically determines which between the dealer and the player the has won the game, or has won the I don't know what the word for this. Basically, which one of the two has won, essentially, based on the hands of cards presented. So there are five possibilities. So the player can win, the dealer can win, the player can win with blackjack, the dealer can also win with blackjack, and then there's also the possibility of the push. That means the draw when nobody wins. Okay, so in order to get started with the writing of the function, we first need to create a type called enum. We're gonna call it winner. Basically, it's gonna contain all the possibilities for winning. So we're gonna have here the winner is the player, the winner is the dealer, or the winner is the player with blackjack. And then you also have the winner is the dealer with blackjack. If you've never played blackjack before, so essentially uh, to win, basically just to win, it's also written in the requirements. The player or the dealer must have a total score less than 21, and then the winner must have a total score less than 21 and also higher than that of the other participant. That means the player or the dealer. And then to win with blackjack, you must have only two cards, and then the total points from these two cards must be 21, and the other player must not have 21. The other participant must not have 21. So this one is push. These are the five possible values, or the five possible values that the winner this enum can have. So the five possible outcomes, five possible outcomes um, when two hands are processed by the blackjack function that we are going to write. Okay, so I'm going to start writing the blackjack function now. So it returns uh, a winner value. The name of the function itself is blackjack, and then the blackjack takes two hands of cards. So there's one hand for still a vector, uh, still a string, so it contains only strings, as we can see in the examples. And then we use const reference because we're only going to read those hands of cards. So this is going to be dealer hand. And then here we're going to have also const still vector, and then still string. And then here is player hand. So the player has a hand of cards, and then the dealer also has a hand of cards. So the first thing that we want to do is we want to do some error handling. Essentially, if a hand is empty, then you have to throw an exception, because a hand should not be empty. A hand should have at least two cards. All right, so I have to include the exception here. So include exception. Okay, and then so first of all, we calculate the length of both vectors. So the length of both hands. So we have size t, which is essentially unsigned int. Size t, dealer hand size. Dealer hand size is equal to dealer hand dot size. Then you also have size t. You have player hand size is equal to player hand dot size. So we calculate the size first of all, and now we can go ahead and do some initial error handling, because we're going to do error handling again when it comes to processing the actual card values. These are the card values. and then you can see that someone can enter whatever they want when or whatever can be entered here. You have to make sure it's a card value before actually processing it. So initial error handling here, we simply write if the dealer hand size is equal to 0, we throw an exception, throw a silly runtime exception, or runtime error, sorry. Runtime error because this kind of error can only be detected at runtime. You cannot detect this at compile time or when you are essentially writing. You cannot control that when you're writing the program because you cannot control what's going to be passed to this function. You can only write the formal parameters. Here you can write here error invalid dealer hand or incorrect, however you want to spell that. Okay, so here you have player hand size. This is second. So this is also if the player hand is empty, you throw again an exception. Throw std runtime error. I have here also error invalid player hand. Yeah, something like that. So now that the error handling is done, at this point here we know that we have at least one card in both hands, which is okay. So what we want to do now is actually calculate the total score for each participant, for the dealer and for the player. So we're gonna write so variables to store the total score for each participant. Okay, so we can write here can actually have size t. I'll just use int dealer score initialized with 0, and also we have int player score initialized with 0. Okay. All right, so at this point here, we want to calculate the total score, but the thing is that the process to calculate, because if you just look at the hands, you'll see that the process of calculating the total score here is the same as the process of calculating total score for the player is the same as the one used to calculate total score for the dealer. So essentially, this calculation of total score can be delegated to a function which is going to be called 2 times. So it's better to have a function that's going to be called 2 times inside here than to have the same implementation twice for both participants. So we're simply going to write a function here. It's not going to return anything. It's going to be calculate total score, and it's going to take, first of all, it's going to take a hand, cd vector, cd string. It's going to take a hand, of course. And of course, it's only going to read the hand. It's going to read it and then give a value for it. So you're going to call this one hand, and then it's going to take also the size of the hand. I'm going to call this one hand size. Well, we can also get the hand size directly from here, but we already calculated it here, so we can simply pass it directly to the function. And then finally, if you want to have pass this variable by reference, it's going to be int score for the score. Okay, so all right. So now we simply need to calculate the score. Okay. So for that, we simply go through the hand. Okay. First of all, we make sure that the card value is a valid one, and then once we make sure it's a valid one, then we simply convert the card value into an integer value, essentially, so that we can sum it and then use it. Okay. So we have for loop. We're gonna have size t I equals 0. So we're going through the hand now. I less than hand size plus I. Okay. So here now, the first thing you want to make sure is that that the card value is an actual card value. So first we get one card. So we're gonna call this one card equal to hand. I. So this gives us one card. So we have make sure card is a valid one. So you have an if statement here. So here this is some sort of error handling again. So if the card is not valid, then we simply throw an exception that there is a card that's not valid. So we're going to write first a condition for a card to be valid, and then we're going to just negate it to get the condition for a card not to be valid. Okay, so the first one is that the card, the length of the card must be equal to, or let's say must be less than or equal to 1, or simply must be equal to 1, as you can see. So basically we are just first working from 1 to 10. For 1 to 9, the card must be equal to 1, and the card must be must be greater than or equal to 1, and the card must be less than or equal to 9. That's the first one. That's the first condition for it to be a valid card. Or the second one, the card may simply be equal to 10. So we can see 10 here. Card with the value 10. So that's the second one. And then finally, this is all from the requirements already. We have J, K, and Q, which count as 10. So the card can also have the value J, K, and Q. Actually, there's no 1, actually, it's 2. It's 2, there's no 1. I think 1 is actually A. Okay, vector, you have to include vector. You have here include vector. Okay. So it's from 2 to 10 here for a valid code, and then you have J, K, and Q. 2 to 10, and then J, K, and Q. So you have the last one here. Card must be equal to J, or card equal to K, or card equal to Q. Okay, so these are the conditions for a card to be a valid one. So the length, first one, the length is 1, and the card is between 2 and 9, and then or the card is 10, or the card is J, or K, or Q. That's a valid card. So now we put this one into a whole parenthesis, and then we just negate it to get the condition. Okay, so now this is a condition for a not valid card by using this negation right here. And then in case the card is not valid, you simply throw an exception. So we have std runtime error. I'll write here error invalid card. Okay, so now that we have sanitized, or we've checked that, made sure that the card is a valid one. At this point here, we simply convert the value of the card into an integer value so that we can actually sum it. Okay, so we have if. So first we start from 2 to 9. We have if the card is greater than equal to 2, and the card is less than or equal to 9. So that means it's between 2 and 9. So what is done is quite simple. So you simply card, not card actually, what's the value? Score plus equal. So you have to do std string to integer, and then you simply pass the card here, because we know it's from 2 to 9. So yeah, and again also from here we already know that this is from 2 to 9, then the length must be 1. We've already checked that. If the length is not 1, and if it's between 2 and 9, if the card is greater than 2 and less than 9, and the length is not 1, then you have already thrown the exception and exited this function. So at this point we don't need to check the length again. Okay, so we just do the addition like this, and then we have else if. So else if the card is equal to 10, But actually, we can actually have this one also here. There's no need to have a new if statement for this one. Put this one here. I have here or card is equal to 10. Yeah, exactly. So if it's equal to 10, then we simply do the string to integer. This is called string to integer conversion, and then we get the integer value from the card. So which means the next one will simply be this part right here. If card is equal to, you can actually just copy it. So if the card okay, so here I forgot A actually. I think A is the last one. Okay, so I have to add A here also. So card equal A. So A is also a condition. Yeah, very important, not to be forgotten. So A, J, K, and Q. These are also valid card values. Okay, so here we have these three here. If we start that, then we simply add 10. Score plus equal 10. So essentially, normally this 10 here should be the constant above here, and then not written as a magic number here, but I'm gonna leave it like this. Okay, then and the final one is else if the card is equal to A. If it's equal to A, then what it's first done is it's just gonna do score plus equal 11 first of all. And then we need to remember that that the hand contains A for later adjustment of the value. So essentially, like it's written here, if the 11 causes the player to, or the winner, the dealer to lose, 1 allows you to win, then go with 1. So we're gonna have an enum here. Enum. We're gonna call this one contains A, and then we're simply gonna have inside yes and no. Okay, so with that is complete. So we can have now we can create a variable here. Not that contains A. Like give it the name contains A, and then we're gonna give it a default value of so this is going to be contains A. Yes. So by default it is yes. Oh, sorry. By default it is no. Okay. And then here, if the hand contains A, then the variable contains A becomes becomes contains A. Yes. Okay. So yeah, becomes contains A and yes. Okay. So at this point here, the card value must have been converted already into well, the total score must have been calculated at this point here because all the possible card values have been attended to 2 to 9, 10, J, K, Q, and A. Okay, so now outside of the loop here, all we do simply is to check if if the score is greater. So we're gonna actually put this one in a constant. We're gonna have here constant max number, which is actually 21. So if you get a score higher than 21, okay, and contains A is equal to contains. So essentially, if the hand contains A, if the hand contains A and the score is higher than 21, then what we do is simply do the score minus equal 10. So that's basically the contribution of A becomes just 1. Because here you add 11, you remove 10, so it remains just 1. Okay. So yeah, that's the only adjustment that is allowed to be made from the requirements. Yeah, from these requirements here. Yeah. So at this point here, the score has been calculated, and then the function has done its job. So what we can do here now is simply can simply call this function, calculate total score. Simply call it, and then we pass the necessary parameters to it, and then we simply get the total score. So we are gonna pass the first. We're gonna do the dealer hand. Then we pass the dealer hand size. Then we pass the dealer score by reference. So then we're gonna have calculate total score. This time we pass the player score. Then we pass sorry, the player hand. Then we pass the player on size, and then we pass the player score. Okay, so these are the two functions, the two function calls used to get the score of the player and the score of the dealer. So now we need to simply determine the winner. So we're gonna start. So we're gonna have here determination of the winner. So we start with if. So if the dealer score mm, okay, so if the dealer score is equal to the player score, so then we simply here we return winner, the push. So the thing is that if the dealer score and the player score are equal, that means they are under 21 automatically, because the way it is placed is that the player plays out his turn until he gets to a final value, until he stands on his final value, um, and if the player is above 21, the dealer will automatically be below 21. So they can never be both above 21 and have the same score. It's impossible. Okay, so we're gonna start with that. Then you have else if. So now we have the dealer wins, I think. We have if um, dealer score is equal to 21 or max number. Yeah, max number. Okay, and dealer hand size is equal to 2. So these are magic numbers everywhere. This one shouldn't be here also. Okay. So here we simply return winner here. We have dealer blackjack. So we just continue similarly. So we have else if you have the dealer score, then you have the player score. If the player score is equal to max number, and well, this part is actually easy, and then player hand size is equal to 2, then we simply here we return winner winner player blackjack. Okay. So then we now deal with the case where so we have if dealer score is greater than player score and dealer score is less than max number. So we return here winner. The dealer is the winner. Essentially, it's common sense. So the dealer has a score less than 21, has a score greater than that of the player, and it's less than 21. So the winner is the dealer. So this is according to the requirements, which is just here. And then finally you have if. Actually, you don't need any else if, simply because when we enter the body of an if statement, we just return. That means we exit the function. So there's no need for an if else statement. So, so if player score is greater than dealer score, and player score is less than max number, then the player is a winner. So you simply return winner player. Yeah, that's it. So if somehow the execution manages to reach this point here, then an exception has to be thrown because it shouldn't reach this point. Throw exceed runtime error, and then here we can write, for example, error invalid hands of cards, something like that. And then with that, the function is complete. Now we can proceed with simply testing the function. So we can test the function, we can test one by one. We can start with the simple draw. Okay, I'm gonna just copy one of the calls to the function, maybe this one, and I'm gonna make it a draw or a push. And of course, everything has to take place in the try and catch block because the function throws exceptions. Catch, catch block, or the exception handler. So you have here runtime error, and here we simply print the message. So cdc out error.what cd online. Okay, so here we simply can call the function, the blackjack function. So you have 2 8j, so you can also have here 8. Yes, and then here we can simply have our winner here. It's gonna store the result. And then we can have our switch statement here with the winner. And then we can have case push. So here we have STDC out. It is a push. No one wins. And then we break. Okay, that's it. So let's try it. Oh yeah, I forgot to do that. Problem with copy paste. Actually, I need to change this one. So that they actually become array literals, which can be used to initialize vectors. So let's see. Yeah, it's correct. It is a push, no one wins. Okay, so we're gonna try now the dealer wins with blackjack. Let's copy this one. So the dealer wins with blackjack. I'm gonna have A here, then remove this one completely. And then here, we can have, so I don't know, reduce this one maybe to 4 here, just like that. This is gonna be winner. Okay, I'm just gonna be commenting as I progress, commenting out. Okay, so here you have a new case dealer, blackjack. So you have here still say out. The dealer wins with blackjack, something like that. STD online and break. Let's see if that works. Yeah, the dealer wins with blackjack. Okay, so now let's go ahead with the player who wins with blackjack. So here we can have maybe 3 here, and here we can have A and then J. So this is 21 if you know how to play blackjack, and this one is 13. Okay, so we write here case player blackjack. Then here we have STDC out. The player wins with blackjack. And then here we simply break again. Okay, let's see. The player wins with blackjack. And of course, if we also have J here, then it's a draw. It's a push, essentially. It's a push, no one wins. Okay, so here was 3 or something like that. So the player wins with blackjack. Yeah, so now you have just 2 more to test because you have 5 possible outcomes. So you have just 2 more to test now. So you have now winner, winner. Well, actually, what am I typing? So now the dealer is the winner now. So the dealer is the winner. So we can have some numbers here. And then here we can have maybe 7. So that's 21. And then we can leave this one like this. This is 16. This is 21. Yes, so I'll write here case, dealer. Then we have STDC out. The winner, sorry, the dealer wins. So the dealer wins. And break. Always write break. Error, invalid hands of cards. Why is this an error? Error, invalid hands of cards. So here I have 21, and then here I have 16. Okay, mistake here. Less than or equal to max number, not less than. Max number should be less than or equal. So here, while it's determining the winners here, it must be less than or equal because max number is 21. So it should be less than or equal because 21 is acceptable. You can see also here from the requirements, if it doesn't exceed 21, that means it can be 21. Okay, the dealer wins now. Yeah, the dealer wins. So we continue with the last one. So this is a player that wins. CDC out. The player wins. C online. And then break. Okay. So I'm just gonna copy this one and simply make the player win with the next one. Okay, so here the player wins. I'm gonna have, I think, I have Q here for once, maybe 1 here, maybe, sorry, maybe 2 here, maybe actually A here, and then here maybe a lower number, maybe 3. Yeah, so now the player should win. Exactly, the player wins. So that's how it is arranged. This is 21 here, and then here this is 16, so the player wins. Okay, so yeah, that's it for this blackjack function. Quite a long function, a lot of code written, and I hope it was easy to follow and clear. So on that, thanks for watching and bye-bye.